Okay, this is on arcs and chords in a circle. Arcs and chords in a circle. Remember, when we're talking about a chord on a circle, remember we're looking at a line segment that cuts the circle, and the two endpoints are on the circle. Okay, a chord, if it went through the center, if it went all the way through the center, then that chord would be a diameter. Okay, but a chord just basically cuts the circle, and the two endpoints are on it. When we're looking at the arc, we're actually looking at the angle. Okay, and we talked about a special angle yesterday. What was it called? If it's from the center out, what kind of angle is this? Starts with a C. Central angle. Okay, and then this would be the arc. Okay, on the outside. Okay, so we talked a little bit about that yesterday. Okay, draw a circle. Okay, this is the best thing about this thing. Change the shape to a circle. Whoop, didn't do very good. There. Draw a circle as best you can. Draw a chord that cuts the circle. Label this point A. Label this point B. Draw another. Try to make them the same length. Label this point C and this point D. Okay. Now where'd that go? Okay. Theorem 10.2 says in a circle, and just use the symbol, in a circle, two minor arcs are congruent. IFF, and we talked about that yesterday. If and only if means it goes both directions. If and only if their corresponding chords are congruent. Okay? The two minor arcs are congruent if and only if their corresponding chords are congruent. So, what that says in this picture, if segment AB, the length of that AB, is congruent to segment CD, then arc AB is congruent to arc CD. Okay. Now, the if and only if part of that says it goes the other way. So if AB, that arc, is congruent to CD, that arc, then AB, the segment, is congruent to CD. And that's because of this if and only if. It goes both ways. Okay? Okay, draw another circle. Okay, draw another circle, and on this one, theorem 10.3, I need you to draw from the center, do a diameter going straight down. Goes through the center. Okay, label the center as C. Label this point up at the top B. Label the point down at the bottom A. Okay. Okay, draw a chord down here at the bottom going straight across. Label this as T and label this point V. Okay, theorem 10.3 says if a diameter or radius is perpendicular to a chord. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. Okay, so by our picture, if BA, segment BA, which is a diameter in this case, because it goes through the center, is perpendicular to TV, then UT, I need to mark this. This is U in the center there. And it's perpendicular, so mark this as a right angle. And that would be a right angle on both sides. Okay. Then UT is congruent to UV segment, and arc AT is congruent to AV. Okay, so we can mark if this is a diameter. Now it could also be a radius, because if I cut it off like that much, if this is a radius perpendicular to a chord, this is my chord, then that radius or diameter automatically bisects this. Okay, it automatically bisects this chord, so therefore this is equal to this. Okay, so mark it that way. So this would be equal to this. Okay, and the chord, the arc, let's mark this arc equal to this arc. Okay. Okay. It has to be a diameter or a radius, and then it will bisect the chord. Okay. Theorem 10.4. The perpendicular bisector of a chord is a diameter or a radius of the circle. And basically you can get that from what we just did up above. So if they tell you that, let's say they tell you CA bisects this chord, then you know CA. Or if they said BA bisects this chord, then you know that is a diameter. Okay? Okay, let's look at an example. Draw another circle. Okay. In this example, circle W, and I'll come back and do the labels. Circle W has a radius of 10. Radius WL is perpendicular to chord HK. Circle W has a radius of 10. Radius WL is perpendicular to chord HK, which is 16. Find the measure of arc MK if the measure of arc HL equals 53. Also, find JL. Okay, picture-wise, circle W, so we know that's the center. W is the center of the circle. Has a radius of 10. Okay, I'm going to label that up here. Okay. WL. Okay, so WL goes straight down. WL is perpendicular to chord HK. Draw a chord going across here. Label this as H. This is K. We know this is perpendicular. Okay. HK is 16. So what do we know? Yeah, and they're labeling this as J. So each one of these is 8. So we know this is 8. We know this is 8. Okay. It says, let's see, label this as M up here. Find the measure of MK if the measure of arc HL is 53. Okay, HL is 53, so we know this is 53. So what do we know about LK? 53. Do we have enough now to find the arc? I can do it more than one way, right? 180 minus 53. Yeah, I have enough to do 180. Shorten it down. 180 minus 53. Okay, and I get what? 127? And that's the measure of arc MK. So there's one answer. Now I need JL.
Which is 6 instead of 8. No. So as diagonal.
I know what this whole thing is, right? I know that whole thing is 10. It bisects the HK. That's how we know that 8. What is WK? Why? Because it's a radius. Okay, you got to draw some extra stuff in here. Okay. I didn't draw that very good. This is 10. Now, do I have enough to figure this?
Yeah, triangle.
Right triangle. What theorem? Pythagorean. Okay, so I'd have, I could WJ squared plus 8 squared equals the hypotenuse squared, Pythagorean theorem. So WJ squared equals plus 64 equals 100. Subtract 64 on both sides. So WJ, yep, WJ would equal 6. Okay, so WJ equals 6. Okay, so JL equals 4. So are they going to make you think a little bit on these? If you have a radius of the circle, then it's the radius all the way around the circle. So yes, you may have to draw in on your picture. Okay, so we've got both answers. Okay on that one? Okay, one more example. No, one more theorem and one more example. Okay, this is theorem 10.5. It says in the same circle, or in congruent circles, two chords I didn't write that very good. Two chords are congruent. IFF, if and only if they are equidistant. from the center. Hang on, I did not put a picture in here. I want to look. Okay, I want to put a circle in there. Okay, draw a chord here and a chord here. Same length. Okay. In the center of this circle, label it L. Okay, make this a perpendicular and make this a perpendicular. Label this one FG. Label this point X. Label this point Y. And JH. Okay. So FG is congruent to JH. IFF, if and only if, LX equals LY. So mark those two distances would be equal. Okay? Okay, last example. Draw another circle. Okay. Example 2, chords E, F, and GH are equidistant from the center. If the radius of circle P, and use the symbol for a circle, if the radius of circle P is 15 and EF equals 24, find, okay, if the radius of circle P is 15 and EF is 24, find PR and RH. Okay, now let's label the circle. Draw a chord up here. Label this as E, this is F. Okay, very similar to what we did on that other drawing. Label a chord here, G and H. The center of the circle is P. Okay. Perpendicular here, this would be Q. And this would be R down here. Okay. Okay, chords E, F, and G, H are equidistant from the center. So what's that telling you? Those are the same. Okay? If the radius of the circle is 15, okay? If the radius of the circle is 15 and EF is 24, okay? EF is 24. This is 12 and this is 12, right? And they're the same, so this is 12 and this is 12. Now, you have to use the radius. They want you to find PR and RH. Well, we already found RH, right? PR. What's the radius of the circle? So what's PH? 15. Draw it in. Very similar to what we just did, Pythagorean theorem, right? So you got PR squared plus 12 squared equals 15 squared, right? So PR squared plus 144 plus 225, subtract 144. 81, you agree with that? And then take square root of both sides. PR equals 9. Okay, so we had two answers there. RH is, okay. Okay, so when they give you a radius, you see how valuable that is? Okay, and if they tell you they're equidistant, so you may have to draw some things in on their pictures. Okay? Okay, that should get you started. They gave it to you. The radius. Yep. Yep. So on these, good to draw your pictures big enough. Don't do a micro mini picture. Draw it big enough that you can see and label it. Okay?